Okay, so what we're going to do is that we're going to derive how to find the area of the triangles in a whole new way. And so what we're going to do is that we're going to start off with the old school formula and work our way into a new school formula. So let's start there. Okay, so we have area equals 1/2 base times height, which is our old school area of a triangle formula. And so what we're going to do is that we're trying to get rid of that height because we saw in the prerequisite skills there that we were just like, we got to solve for the height, and that can be kind of an ordeal. So let's do this, okay? Is that we're going to start in this position in each one here with this angle A, all right? And I'm going to build both of the formulas in regards to that, and we're also going to go ahead and take a look at how to switch in the base, which we know that is going to be C right here for each one of these, okay? And how to go ahead and get rid of that height right there. So let's start to put the pieces together that we already know. All right, so bringing things down, we would have 1/2. Okay, and the base in this case is going to be, that rhymed, is just going to be that length of C, okay? And then we would still have height, which we know we want to get rid of because it's just kind of a pain, as we saw. So as we're putting all of these things together, we think about, okay, well, how can I tie in height and a known side? Because usually the sides of a triangle are easier to find than the height. You know what I mean? Like this part right here. That's not always the easiest thing to find. But the sides of the triangle, we have many different ways that we're going to learn to be able to find those. So what we're going to do is that we're going to, in each one of these, tie in height to the angle A and that side B. So what I'm going to do right here is that I'm going to write out that the sine of angle A equals H over B. Okay, so it'd be the opposite over the hypotenuse. And likewise, this one on the right-hand side is going to need a little bit of setting up. Since this is angle A and this is a straight line, this angle right here is going to be, and I'm going to have to write this off to the side, 180 degrees minus angle A. So it would be fair to say the sine of 180 degrees minus angle A is going to be the opposite, H over B, okay? So, on the left-hand side, we have, kind of going back and forth, trying to isolate H out of there. We have a pretty easy job, because if I multiply each side by the length B, these are going to cancel out, and I'm going to get the height equals B, side B, times the sine of A. And so I can make this switch right in for here, and the new school area is going to be area equals 1/2 C times B times the sine of A. Okay, and to clean this up, I'm going to write area, this is the way that it's typically written, 1/2, okay, B, C, sine A. Not much different. But the way that we're looking at this is the following, and I'm going to, this picture right here, kind of get rid of this, and then we'll work on the other one in a moment, is that if you have an angle right here, if you take the sine of that, and you have, it's called an included angle. So angle A would be an included angle, and the sides that make the angle, B and C, right here, okay, and the sine of the included angle A, if you take half of their product, that's going to give us the area of that triangle. Notice that the need to solve for h is gone, which is nice because, again, angles and sides are easier to find just than rather than the height. Okay. Now, going back to this one on the right-hand side, what we're going to do is that we're going to take a look at this part right here, because we got 180 minus a, and it's like, uh-oh, what does that equal out? And so going back to our trigonometric identities, let's take a look at how to get this thing, that 180 minus a, simplified so we can move on. Okay, so we have the difference formula for sine there that we worked quite a bit with. And if I were to plug 180 in for y, and I'm sorry, for x, and a in for y, I would get the sine of 180 degrees cosine of a minus the sine of a cosine of 180. Okay, so notice that when I start knocking things out, that the cosine of 180 degrees is 0, so that, I'm sorry, the sine of 180 degrees is 0, so that cosine is going to cancel out, and that's going to leave us with a negative sine a, and cosine of 180 degrees we know is a negative 1, so a negative 1, these two negatives are just going to give us sine a. So that ends up working out to be, funny enough, the exact same thing. And that's why the formula is so slick, because it works with an obtuse triangle as well as an acute triangle. So using the same method that we did before, we're going to multiply each side by the base, and we're going to get the same part right here. Okay, canceling these out. And so at the end of the day, we end up with the area is going to equal 1/2 b times c times the sine of a. So that shows that the formula works for obtuse triangles as well as acute triangles. Okay.